Welcome to Bald Guy DIY. In this video, I'm going to tell you what rectifiers are, why we use them, and some of the cool ways that I've seen them used. If you've clicked on this video and seen the term rectifier, you might be wondering, what in the world is that? A rectifier takes AC or alternating current and converts it to DC or direct current. If you don't understand the difference, take a look at this drawing, which shows that AC is a constantly changing waveform that has both positive and negative components to it, where DC is just a constant current flow in one direction. AC is really common in our homes because it's easily transformable, as I covered in a previous video, and it allows us to transmit it easily over power lines and then bring it down to a safe level for use in our homes. Devices like incandescent lighting don't care if the supply to it is alternating or direct, and so they work the same either way. They just have to be created for the right voltage and current flow. Things like motors can be designed for AC, and in fact, AC motors are often more efficient, especially when we get into three-phase motors with less maintenance than their DC counterparts. Where AC is not very useful is in the world of electronics. Electronics typically require a nice stable voltage, and they need direct current because they can't handle the positive and negative fluctuations of AC. Hence the need for rectifiers. In the simplest way, we could just say a rectifier converts AC to DC. The first rectifiers were actually made in the 1870s, as there was the struggle between AC and DC, the whole Tesla versus Edison, and what type of electricity should be generated and transmitted to our homes. The modern birth of electronics, though, were really in the late 1940s and into the 1950s, and that really saw the need for all of these new technologies and the things that could be created from them. One of the most incredible building blocks is something called a semiconductor. In our primitive thinking before that time, we either thought of all materials as being a conductor, which means electricity could flow easily through it, or an insulator, which meant that electricity would not flow through it, or it wouldn't flow through it until it was a very high value of voltage, in which case it would probably destroy the thing that the electricity was attached to. Obviously, things like metals, copper, aluminum, gold are great conductors of electricity, and things that make good insulators are things like wood or ceramic, usually plastics. Those kinds of things don't conduct electricity very well. Semiconductors are incredible because they conduct electricity at some time during certain conditions, and at other times they won't conduct electricity at all and act like an insulator. These characteristics make it possible for a whole myriad of inventions beyond that: transistors, diodes, SCRs, all sorts of things, but they come back to this basic concept that we can control when something conducts electricity and when it doesn't. What makes a rectifier unique from another conductor is that it only allows electricity to be conducted in one direction of current flow. That means if you were to hook up DC current to it and you connected it properly or in the way that it was meant to flow, electricity would flow normally through the circuit with a slight voltage drop. But if you were to hook that DC current up in the opposite polarity, it wouldn't flow at all. It acts like there's an open switch. If you were to put AC through a simple diode, though, what you would see is that it would allow voltage to pass through on the positive cycle when it's properly biased or properly connected, and nothing would pass through on the negative cycle, or vice versa if you had it switched around. What this means is that you can control when it conducts and when it doesn't, and you can put AC in on one side and get current that's all the same polarity on the other side. Now, rectifiers can be as simple as a single diode, or combinations of diodes or other types of electronics can be stacked together or arranged in a certain way so that they make use of the entire AC waveform. A simple diode is only going to allow electricity to pass through when it is forward biased or having the correct polarity of current. So a single diode is only going to allow electricity to flow during half of an AC waveform. In other words, you're only going to get half the voltage flow than you would out of a regular AC circuit. If you combine multiple diodes together, you'll need either 2 or 4 diodes depending on the type of rectifier. You can create a situation where both sides of the waveform are transmitting current, but they're all doing it in the same direction. Instead of getting that waveform that goes all the way to a peak value and then all the way down to a negative peak value, you'll instead continue to go from 0 to the peak value, 0 to the peak value, and all of them on the positive side. When you add in other things like filters and chokes, you do get a nice smooth DC output, but the concept of a basic rectifier is that electricity will only pass in one direction, and then what you do to condition that signal and make it nice and usable depends on the kind of device you're running and what kind of results you need to get from it. These two different kinds of rectifiers are called either half wave or full wave because they transmit either the half of a sine wave from AC or they transmit the entire full wave. As you can imagine, the full wave allows a lot higher voltage and a lot better current flow because it's more consistent, not having these gaps or pauses when the AC voltage goes below 0. There's a ton of things you could say about rectifiers, how they work, the calculations that are used to convert from AC to DC, and all of those things, but just basically know that rectifiers are used to take that alternating current and convert it into a constant direction flow of current on the other side of the rectifier. Our homes these days are full of electronics that require direct current, and so rectifiers are used over and over again, often in combination with transformers to get the voltage that we need on the output side. Things like our cell phones or computers, laptops, all of those things use direct current, and so we have rectifiers all over the place. A simple diode might cost just a few cents, and large-scale rectifiers used in industrial applications might cost thousands of dollars. The most common use is definitely just to create a basic DC output, but I've also seen rectifiers used in a couple of really creative ways in order to produce some extra functionality. One cool use that I've seen is in the case of a light that had two settings, a full brightness and a half brightness. They used a single diode in combination with a full rectifier in order to only transmit current half the time, which meant that we would get half the brightness of the light and a very simple way of having two different modes, a half and full bright lamp. Rectifiers can also be used in combination with capacitors to create voltage doublers or triplers. They end up being used over and over again in the smallest electronics all the way up to large appliances. And once you start looking for them, you'll see them all over the place. What's the most interesting use of a diode or rectifier that you've seen? Let me know in the comments below or send me an email. I'm always happy to hear from you. If you'd like more information on how rectifiers work or how semiconductors are used in many different kinds of electronics, let me know and I'll use it as inspiration in a future video. If you like this kind of content, please give it a thumbs up, subscribe to the channel, and check back every week as I post a new video every Saturday morning. Until next time, in all your DIY projects and solving problems that need rectifying, don't be afraid to be balder.